Hello everyone, in this session we are going to talk about the chromatography for the purpose of analysis of analgesic tables. So this method is using for separating compounds, and also we want to understand what is the unknown materials that or unknown composition that we have. So usually we have uh, one or two unknown and three to four known composition. So this method is going to use in order to separate unknown and identify unknown based on their difference in polarity. As you see in this session, in this slide, uh, we have two phases, a liquid phase and a solid phase. And inside the liquid phase, we have uh, two composition A and B. So they are moving from left to right. And you see that at the beginning, there is a kind of equilibrium between adsorption of both phases to the solid phase. But we know that B as an unknown material, for example, has a more attraction to the solid phase. Why is that? Because it is more polar than A. We know A is less polar than B. So as you see, uh, phase B is gonna stay in the left because we have a movement from left to right, so it's gonna stays in the it's gonna carry a longer distance, shorter distances, and A is gonna carry longer distances, and is gonna be close to the uh, right side of our movement. So we need to use a plate, which is usually silica gel, hydroxylated silica, and on we with the aluminum oxide. These substances are very fragile, so we need to support this plate with uh, a watch glassware. The moving phase is usually an organic solvent or a mixture of organic solvent. Polar solvents tend to cause a rapid movement of substances. So here you see an example of uh, an eluted thin layer plate, elution of the black ink. We put an unknown material on this the line on the green spot, and you see at least we have a 4 to 5 different composition, and they are gonna stay based on their difference in polarity, and they whenever we have the more polar, they're gonna uh, absorb in shorter distances. And as you see that in this slide we have three materials, ortho, meta, and para. You see that ortho, because it is less polar, is gonna go to the uh, larger distances, and meta in the middle, and para, because of the higher polarity, is gonna go to uh, shorter distances. And for the mixture also, you see that we have the different spot, and you see that there are two spots more visible because we had more phase of the more para and ortho phase in the mixture. So they went so at the dissociation we are see para and ortho phases we see less amount of meta. And in this slide, you see if we have the um, materials that they don't show any kind of difference in the color, what we should do, we are going to use the fluorescence light and fluorescence plate, actually UV light and fluorescence plate, to dissociate the distance that they move. So here we have an example of illusion of a thin layer plate. We have three spots from the same materials, but with a different size. We put the plate into the beaker. Beaker has amount of liquid phase, which is the solvent. We want to make sure that the line of the spot stays above the line of liquid. We don't want the spot touch the liquid. So after a while, you see that the liquid penetrates in the plate and goes above. So you see, because we have two different composition in these three spots, we have the difference of the distance that they can go above the plate. After a while, you see that we have three blue spots and we have three red spots that after we derive the plate. So based on the distance from the early line, number one, we can make a equation, and this equation help us to identify the unknown materials. In the next slide, we explain the mechanism better. So we have three spots that they have stays in the different distance from the line 1. We have line 2, line 3, and line 4 for this, which is the distance of the silica gel. The whole plate doesn't have the silica gel in the whole plate. From 1 to 4, we have only silica gel. So you see we have the D14 for the silica gel. We have the D12 for the blue lines, and we have the 13 for the red lines. We can measure these distances. So for RF, for spot 2, we have D12 over D14, and for RF, for the red line, for the lead spots, we have D13 over D14. So this is the RF1 and this is the RF2. We can go and see the retention factors in the table, in the handbook, and find the unknown materials based on their retention factors. That's the mechanism of this chromatography experiment. So more porous solvent generally lead to faster elution. If we have a more polar solvent, we can do the experiment faster. The ideal solvent system is that which best separate the component. How we should choose the solvent? A solvent is the good solvent that we can separate a good number of the phases inside the unknown materials that we have. So this is a table for increasing polarity. You see that the expected elution order of the organic classes and eluting power of the organic solvents. You see how they, based on their increasing polarity. Generally, we are going to use this type of organic compounds in the experiment in the lab, so you see their structure and their formula. This slide is just makes you familiarize with the compounds we are gonna use in the lab. So the least polar compound is gonna go uh, larger distances. Least polar and fast moving analgesic spot on TLC plate. So you see that the structure of nonpolar alphatic components will have the less attraction to the substrate and will move faster, so they can go larger distances. A structure with multiple OH or NH, because of their higher affinity to the plate, they're gonna move move slowly, and they are gonna stay to the shorter distances in the plate and will more strongly bond to the H bonding of the silica gel. So we have the plate in this slide. We are gonna put 4 or 3 spots on the line that we drew before, and then in this slide we showed to you that we are gonna put 4 or 3 matte composition on top of each slide. We want to make sure that they have enough space between each spot. So we usually using 2 known and 1 unknown. In this slide, we are explaining the essence of the word. If we have a 3 unknown and 4 known, we are gonna use each unknown with the 2 known with the 3 plates. So imagine we want to use the elution solvent system. The solvent that we are gonna use, they are the ratio of 112 glacial acetic acid and 1,2 dichloroethane, and the other one is the ratio of 5:1:1:2 volume ratio of 1,2 dichloroethane, acetone, 95% ethanol, and hexane. And the third solution is gonna be 25 to 1 by volume ratio, ethyl acetate to glacial acetic acid. These are the 3 solvents that we are gonna use for our experiment in 3 different plates. So you see that we are gonna have 3 spots, and then after a while it just gonna go, the solvent is gonna penetrate to the plate, and the spots is gonna carry by the solvent. So let your plate dry. Examine all your plates under UV lamp. Circle a spot with the pencil. Calculate the record RF values in your notebook, and based on their RF or retention factor, determine what type of unknown materials that we have. So here is the example of the plate that we are going to see at the end of the experiment. For example, you see that we had 2 known phase and 1 unknown phase. So you need to know that do not touch the face of the plate with your fingers. Only use pencil to make a mark, and stop the elution before it reaches the top of the plate. Make certain that the solvent does not touch the bottom of the spots when you place the plate in the elution beaker. Cover the beaker with the watch glass during the elution, and at the end we need to make sure that we careful about the safety, and we want to have the safe area of working. Thank you for considering this lecture.